Okay, everyone, this one is 1.5 topic. Form 5, there's a sound wave, 1.6. Okay, so now we go and every student go through your notes. Okay, we go to introduction first for the sound wave. Okay, let's see here. First one, we need to know sound wave. Sound wave is produced by the compression, okay, and also rarefaction. They must through the medium. Okay, remember what's a compression, what's a rarefaction? Compression is when the molecule, when they move closer, okay, when the molecule they move further, we call rarefaction. Okay, you want to produce the sound wave, first one, compression and rarefaction must be continuous to happen. After that, the sound wave can be traveled. Okay, so this one we call it sound wave. They must through the medium. Okay, must have the A molecule to help the sound to travel. Then after that, we can listen it. Okay, now we go and see the sound wave. Here got definition. Okay, the definition say the sound wave is produced by the mechanism which produce the process compression vibration of the surrounding medium. Characteristic. Okay, let's see the characteristic. Okay, first one, we already know the sound wave is a longitudinal wave. Okay, longitudinal wave. Longitudinal means the molecule is vibrate, perpendicular or parallel. That's a parallel with the direction of the wave propagate. So this one we call longitudinal wave. Okay, number two, they cannot travel to the medium for the sound wave. What can travel? Light and also the water. They can travel to the vacuum. That one is a transverse wave. Okay, so first one cannot through vacuum. Number two is a longitudinal. Okay, number three we need to know is the speed. The sound wave, how to travel. The speed of the sound when they travel, solid, liquid, gas. Three also can be traveled, but we need to know the speed. The highest speed is solid. Reason? What's the reason they can through the solid faster and the gas becomes low? Okay, because of the particle. Okay, solid, there's a full with the particle. Arrangement is closer. Okay, when the arrangement is closer means the sound when they travel through the medium, they are faster. Okay, they are faster, go one by one. After that, they can travel to each other. So this one is sound, they will travel faster through the solid. Then the last one, the lowest, is a gas because the molecule is far away. You need to find one by one. After that, they can travel. Okay, so this one is a simple characteristic for the sound wave first. Okay, now we will go through the sound wave pattern. Okay, let's see here. Here got the pattern. Okay, now we need to explain. How come the sound wave can travel? So this was one of the questions for a process question, 4 marks. They ask you why the sound can be traveled until you can listen. Okay, so from here we need to one by one, 4 marks, they make at least 4 points. Okay, now we're going to see the structure. The structure of the sound wave. Okay, first one, we need to say about compression and rarefaction. So the first sentence, they say the sound wave from the loudspeaker produce compression and rarefaction of the A molecule. So the first one, we're using the diagram to explain the whole process. Don't memorize one sentence by one sentence, just using the keyword. Okay, now we're going to go and see the first step. First step, you must say the first one, they say sound wave from the loudspeaker, they produce by compression and also rarefaction of the A molecule. Okay, number two, you must say what means of compression, what means of rarefaction. Okay, compression means, second sentence, when the molecule push forward, okay, to the left, example, push forward, they go to the left. Okay, after collision with another molecule, they move backwards. So one go backward, one go forward. Finally, they have become closer. When they become closer, this one we call it as a compression of the sound is produced. Compression of the, not compression of the sound, it's compression of the molecule is produced. So this part we call it compression region. Okay, so from here they say after collision with the A molecule in front and backwards, after that they produce a compression region. Okay, number three, you must explain the excuse me, reverse sentence. The reverse sentence means when the A molecule then move forward, okay, another part of the molecule move backward. Now you find it, this part molecule is far away each other. Okay, when they're far away each other, means this part is create what region? Rarefaction region. Okay, then after that, you must say these two regions must be continuous, repeated. So from here, between the compression and rarefaction travel repeated, sound wave can be travel. So this one is the 4 marks question, how you need to explain the sound wave to travel until you go to the eardrum. After that, your eardrum vibrate, then you can listen. Okay, you must mention about the compression and rarefaction through the medium. Okay, you explain how the compression is happen, how the rarefaction will happen. Then after that must be repeated. Okay, so this one is a process. Okay, then we go to the the following. Okay, the following is the speed of the sound. Okay, let's see the speed of the sound. Sound is travel quickly, but not as fast as the light. Remember, the light is 3 times 10 power of 8. This one is the light, 3 times 10 power of 8. Okay, but the sound is less than light. Okay, now we're going to see the, okay, number 2. The sound travels faster in the liquid and lowers in the gases. Okay, the sound wave in the gases increases. Okay, now we're going to see this one. This one is just go through the gas. Okay, we don't want to compare the solid, liquid and gas. We're just talking about the gas. Okay, speed of the gas for the hot gas should be higher. Why the speed for the hot gas should be higher? First one we need to see is vibration. Hot. Hot means hot air, warm air. Okay, hot air means the temperature should be higher. Temperature is higher means how about the particle? The particle will vibrate faster. When they vibrate faster means the frequency increasing. Frequency increasing, okay, now we refer the formula. V equal F lambda. Okay, lambda is constant. So you find it when frequency increase, then the excuse me, then the speed of the gas will be increases. So this one is the first characteristic. The sound wave will travel faster in the hot gas. Okay, number 2, sound wave also travel faster in the low density gas. Low density gas means warm air. Warm air and cool air. Warm air is low, less dense compared to cool air. So I find it, the speed of the gas also very fast for the low density gas. So that means we just compare gas and gas lah. First one is hot gas. Okay, high speed. Number 2, density low, then also high speed. Okay, number 3 is temperature. When the temperature high, the gas also travel fast. Okay, so this one is the 3 characteristic of the how the sound waves travel. Okay, last one is speed, not related with pressure. So we don't care you are high pressure or low pressure, the speed of the sound wave is the same. So there's a not related with the pressure. So this one is a characteristic for the sound wave. Okay, next we go to the frequency. Okay, we're going to see the frequency for the normal human being. Okay, normal human being, we just can listen is between. Okay, range is just 20 Hertz to 20 kilohertz. Okay, this one is normal human being can be listened. If less than 20 Hertz, we call it as subsonic. Subsonic. Okay, when they're above, we call it as ultrasound. Okay, so this one we call high frequency sound. This is a low frequency sound. Okay, now we're going to see the relationship for the sound wave. Sound wave just got 2 things you need to remember. One is amplitude. Amplitude. Okay, number 2 is pitch. Okay, amplitude is stand for the, normally amplitude with energy is the same meaning lah. When I say the energy higher means the amplitude become higher. Okay, now from the sound wave, the amplitude is represented by using the loudness. Okay, loudness. So if I say amplitude high, okay, so that means you produce the sound is louder sound. So now we are using the wave to explain the louder sound. This one is a normal sound. Okay, when you say the amplitude become higher, there should be, okay, I draw by black color. Okay, this one we call it amplitude. Amplitude become higher. This one we call louder sound. Okay, so these two is a directly proportional. Okay, pitch. Pitch is related with the frequency. Okay, frequency. What means a frequency? Remember frequency. Frequency is 1 second. You can vibrate how many times, we call it frequency. Okay, so from here we're going to see the wave graph of the frequency. Okay, if the normal, okay, I draw with normal. Okay, this one is 1 second. Okay, 1 second I do how many times of the oscillation? 1.5. Here is a 1, after that half. Okay, if I say high pitch means frequency high. Frequency high means 1 second I can do more than 1.5 oscillation. So from here example, okay, but the loudness is the same, so I can draw okay like this. Means you can see 1 second I can oscillate how many times? 1, 2, 3, 3.5. So this one we call high frequency. High frequency, the meaning also we say high pitch. Okay, loudness and pitch is a different. Loudness means you can hear the sound become louder, but they do not make your ear become very hard to listen. Okay, pitch means the sound become very sharp. Sharp until your ears is cannot control. Cannot tahan, you want to close your ear. They want to be called high pitch. Example, I'm using the I'm using some become the sharp object. I go to scratch. I go to scratch some solid object. So you listen, the sound is high pitch. So that one is, you can feel it. You can feel it. Some eardrum is vibrate too sharp. That means you want to close your ear. But louder is a different. Louder, that means the sound volume become higher and lower only, but you still can accept it. That one we call loudness. Okay, so from here we can conclude what we learned about the loudness and also the pitch. Okay, loudness directly proportional with the amplitude. Okay, number 2 is frequency, directly proportional with the pitch. High pitch, high frequency. Louder means high amplitude. Okay, here got the graph. Okay, you can see this one is a quiet sound. Quiet sound, you see the amplitude become less. This one is a louder sound. Louder sound, you see the amplitude become higher a little bit. Okay, now we're going to compare the pitch. Okay, lower pitch. Now the amplitude become constant. 1. Okay, lower pitch. Here got how many complete oscillation? 1, 2, and 3. Okay, now we're going to see the high pitch. Okay, high pitch. You see the graph. Still 1 amplitude, but you see they can do so many times. In the time taken is the same. So this one we call high pitch. Okay, then we're going to see the different quality of the sound. Okay, different quality of the sound they produce, the wave should be different. Okay, we can see the tuning fork. There's a flat one because the sound is a sweet one. The sound is normal. Okay, this one is piano. Piano, they produce the shape also different. Okay, this one is a violin. Okay, then this one is the noise that you every time to produce in the class 1. That one is like this. Okay, this one is a tone, normal sound. Okay, this one is a sound pattern. Okay, now we go through the application. Okay, first application, they're using the ultrasound. Okay, application, the first one using ultrasound. Okay, ultrasound, what's the function? The function is scanning, detecting the echo detecting the echo, come back. From where? Okay, the first one you can say detect from the mother wombs. The mother wombs. Okay, when you got unborn baby, that means the mother want to scan. See inside the baby how the location, how about the sedation. So what they can do, they apply the gel at the stomach there. After that, they will go to scan. Okay, first one, the question normally will ask why they apply the gel. Just a simple only. The gel first one, okay, you can say about easy to scan, easy to move the transmitter. Reason, reduce the friction. After that, they can contact easily with the surface of the skin. So this one is why they're using the gel. Okay, number 2, why are we using the ultrasound? Ultrasound is high frequency compared with the normal sound, so high frequency. Then the next question they will ask, why we never using the X-ray? X-ray is too high, frequency too high already. This one is high. The X-ray is too high. So too high, that means they can give the harmful, okay, dangerous for the unborn baby also. So this one why we using the ultrasound. So the process, they say ultrasound, you can say the ultrasonic. Okay, the scanning the medical involved of the ultrasound wave into the patient body. Okay, and also detect the echo which come back. So the baby, so this one the baby is inside. Okay, you are scanned. Okay, scanner. Okay, you are scanned. Okay, you move up and down. When you move up and down, that means they can send the ultrasound. Okay, the ultrasound you send inside. When they send inside, they will reflect it back. They're using the refraction of the sound echo. They will refract it back. Okay, so from here, they refracted back different part of the body. You can get a different result. Maybe the outside body of the baby, they will absorb less of the sound wave. After that, they mean they refracted more information outside. So by the inside body, they absorb more. Then they absorb more, that means they cannot refract it too much. So you find it when you see the image from the computer programmer, you find it they just got the shade. Okay, it's just a small shade. After that, the color is a black. After that, you see it not clear. Okay, so this one is the condition when you want to see. Okay, the second one is the shade. They're using the echo sound. They want to find out the depth of the seabed. Okay, this one is your shade. Okay, this one is your seabed. That means you need to send. You need to send the sound wave, detect what is the depth. Okay, after that, they will refract it up. So send and up. So from here, another function. First one is scan detecting the unborn baby. Okay, number 2, they can detect depth of seabed. Okay, depth of the seabed. So from here, we need to know they're using what equipment to detect the depth of the seabed. Okay, first one, you must have the transmitter. You must have the transmitter. Okay. Number 2, you must have the receiver. Okay, number 3, well, you get it. Number 3, you must have the CRO, cathode ray oscilloscope. This one, you want to see the wave pattern for the TV, like a TV on a screen. So you want to see the sound when they're refracted, what's the situation. Then you need to count the time taken. So from here, when you want to detect the depth of the seabed, okay, this one we got one of the formula for the sound wave. Okay, normally before that we learn velocity equal displacement over time. This one is before that we learn. Okay, speed. Okay, now for this one situation, because all the sound travel and come back, this one is a two-way system. Then you send, then you come back. Okay, so that means the time taken, you want to listen or you want to get the result from the ship. They want to detect the seabed, the sand, and they come back. Then we need to know the time taken. Already is two-way. Is it? You send, then after that you come back, then you on the CRO, they will join with CRO. Okay, that one, the time taken already is two-way. Okay, the second one, speed. The speed you set, then they come back. We already count that also is a two-way speed. Okay, the problem is that we never cover two-way. That just one way only. That. So from here we want to find what is the depth of the seabed. Okay, the formula is VT equal to D. Everything we take two-way. Okay, speed already is two-way, time taken is a two-way, but the depth you need to times 2. Then this one is the whole formula. So finally the question will ask, what's the depth? So you need to take VT over 2. That is the depth. Okay, that's the depth of the seabed. Okay, then the number 3. Number 3 is a sonar system. Okay, sonar system also using the ultrasound. Okay, the sonar system is stand for sound navigation and ranging. Okay, used to detect the shore of fish. Okay, they want to know beneath there where's the location of the fish. So they're using the sonar system. Still the same thing. Send the sound by using transmitter, ultrasound. After that, refracted back by using the receiver. Then also CRO, we need to count about the depth, where's the location of the fish. So that one is a sonar system. The equipment detect refracted path from the shore and work out its position and also the depth. So the diagram like this. This one is a diagram, how they want to detect the shore of the fish. So this one is a sonar system. Sonar system just talking about detect the shore of the fish. Okay, detect the depth of the seabed. We never say about sonar system. Okay, after that, there's your example. Okay, let's see the example 1. Okay, this one is a notes. Okay, all inside your paper already. Okay, example 1. Okay, for the sound wave, all the questions they ask about the depth. So remember, sound wave, when they ask about the depth, remember the depth is divided by 2. We just got one situation. The depth is no need to divide by 2. We didn't call it depth, that is distance. Okay, example, there's a lightning. When raining, already before raining, you got lightning. Okay, you are standing here. Okay, now you go and see. You see the lightning. Then they ask you, what is the distance? What is the distance for the lightning? So from here, first one, speed you need to know. Speed is how many? Okay, number 2, the time taken. Okay, the time taken, is it two-way or one-way? This situation is two-way or one-way. This one, lightning. Okay, lightning not related with the ecosystem. We didn't say about the echo. Okay, lightning, when they strike, okay, then after that they must go to transfer, after that come back, then I listen. No. Okay, lightning just one way only. So lightning, when they ask about the distance, we straightforward, V equal VT equal D. That's all. No need divide by 2. Okay, because they're straightforward, we can listen, we no need, not a refraction of the phenomena. Just a normal speed and also distance, time taken. Okay, example 1. The sonar signal. Send a vertical downward form. The shape is refracted from the ocean floor and detected by microphone on the key 0.8 seconds after transmission. So the time taken, two-way transmission already, is 0.8 seconds after transmission. Okay, if the speed on the sound water is 1,500 speed. Okay, now they ask what's the depth of the ocean. So it's the same thing. V equal D over T. Okay, so from here, 2D equal VT. Okay, you want to find the D, so D equal VT over 2. So we find it, there's a 1,500 multiplied with the 0.8 and divided by 2. That one is a depth. So the answer from here we get it, there's 600 meter. 600 meter. For the first example question. Okay, now we go to the second question. A man that stands in front of a fairly large of the flat wall, distance 50 meter. Okay, second question. Distance is 50 meter. Okay, the man is standing here. So it's a wall. Okay, this one is a distance 50 meter. Okay, now he claps his hand in the time for 20 intervals between the clap is 12 seconds. Okay, 20 times. Come and back. So you find it, they're using how long? 12 seconds. So that means I need to find out 1 times. The time taken is how long. So I need to divide. I take the 12 seconds, divide by 20 first. So I get it, there's a 0.6 second. It's 0.6 second. Okay, the next one. So what is the speed of the sound? What is the speed of the sound? This one, the sound already is a refracted sound. Go and back 2 way. Okay, now distance is 1 way only. Now they want to find about the speed. Speed is a 2 way of the sound. So we're using formula V equal, okay, remember the D you need to times 2. 2 times 50 over 0.6. So I get the answer is 166.67 and S negative 1. So this one is the speed of the sound wave when they go and back, come and back. That one. Okay, that one is an example. So the rest, the tutorial question 1.6. So I can give you the answer first. Then after you do, then you can check it. Okay, must do it before you want to check. So I write here